because we've talked about it multiple times. What did they give you?
One, I'm trying to find what number one was. I don't remember.
So looking at question number 1, what did they give us?
Dang.
F prime and then a value of F.
Well, I'd probably go in order. So they gave us a value of f, then they gave us f prime, and then what did they ask for?
F of 3.
So what kind of question is that?
One that I don't know the answer to.
If they give you one value and they ask you for another value, what kind of question is that?
Isn't that fundamental theorem of calculus?
Yes, that is your FTC. That is guaranteed to be on your exam. There is no way that is not going to be on there. Hands down, 100%, no questions asked. They will ask this question in some way or another. They will give you a value, they will give you a function, and they will ask for a second value. You will use the FTC. Clearly, it's the fundamental theorem of calculus. There is no way that the FTC is not going to appear on your AP exam. I don't care how they're doing it, what they're changing. This will appear on your exam, hands down, no questions asked. It is a calculator question, so you're not meant to do that integral by hand, but guaranteed you will be doing this question on your AP exam. So remember, your integral from a to b of f prime is equal to f of b. If they give you, obviously they'll give you a and b, but if they give you two of the three things, you're going to find the other one. In this case, they gave us f prime, and I think they gave us f of a, if I'm not mistaken. They gave you those two. You just have to find the third one by using your calculator to do the integral, and then plugging in f of a of being, yeah, they give you f of 1 is pi over 2. So plug the first part in your calculator, integral from a to b, and then that equals that. Remember, you get points for showing your integrals and things like that. You need to write this out. So you would do the integral of f prime, so specifically in our problem, you would need to write this. And don't forget your dx, technically. You need to show this line that I have on the board. I'll be up in a second. You need to show that. You will get points for that. That's called your integral point. That's showing, hey, I know this is the FTC. And then obviously evaluate things from there. But if you write that line, that's a point usually, and then you get like the answer point of some sort, or evaluation points or something. Okay, so I'm not going to finish that because you can put that in the calculator. I have faith that everybody can put an integral in the calculator. Number 2. This one is kind of a tricky one if you're not careful. So doing the integral of that function there does become a little bit hard. Is this calculator? Yeah, this is calculator. So even with the calculator, you can't put like a g prime type thing in there, so you don't really know what to do. So you have to end up doing a u sub. There's a black marker. Any better? Yeah, it's pretty good. So is it g prime of x? N squared. Is it 2g of x? Like plus 3, I think.
Plus 1.
I think so.
Plus 1.
Oh,
Okay.
plus 1.
For some reason, they like to change those numbers from AB to BC, and I don't know why. What are my integral bounds? 0.3. Okay. So even though this is calculator enabled, you can't put that in the calculator. Your calculator can't take in functions. It can only take in x values. You can't do like x prime and things like that. That doesn't exist. So instead, what we had to realize, this is a tricky one, in that we're going to do a u sub, and we're actually going to let u equal to g of x plus 1, and then du is 2 g prime of x, which means that we get 1/2 du, don't forget dx, is equal to g prime of x dx. This is not the easiest substitution. That one's marker's dying.
I
This is
took a use, or I tried to do just take the antiderivative without u-subbing it.
you won't be able to take the antiderivative of cosine squared.
Oh.
Not by itself like that. So that's the problem.
Okay.
So and especially notice what kind of question is this? What do you get to use?
U-sub.
A calculator?
Get to use a calculator. Never try to do an antiderivative by hand on a calculator question. It will not usually end well for you.
I mean, I knew that. I just forgot that u-subs were like a thing.
That's why we're going over these things. This is not the easiest U-sub, I'll admit that wholeheartedly. It becomes a relatively difficult problem if you don't realize that's what you're doing here. You're going to look at it and go, how the heck do I do this? What do I do? I can't, like, what? So I don't necessarily, this is one of those what I would consider more difficult problems. So if you didn't understand as you looked at it, don't worry. Like, it's not the end of the world. That's why we do these things and go over these things so you get experience and get used to them. And it pushes you to think and understand and figure out, what do I do when I don't understand? Like, how are you going to react on the exam to that? That's one of the reasons why we do these types of things, is so that you get experience and you get that feeling of, crap, what do I do? How do I figure this out? And that way you can help yourself to try to prepare for that. Because there's going to be things that you've never seen before on the test. They're going to figure out a way to craft a question that you may not have seen it that way before, but it still uses all the same fundamental theorems that we've used in calculus. So at that point, not too bad. So when you do your integral, you u-sub. So this becomes cosine squared of u. And then the g prime of x dx, which is that part, turns into 1/2 du. So I'm going to move the 1/2 out front, du. So when you do your u-sub, you should get that. Now, one of the mistakes that we've talked about a lot that people forget about, what happens to your limits of integration when you do a u-sub?
Wouldn't you have to have u values like for the bounds?
Yes. So when you start the problem to 0 and the 3, those are x values. We can't do x values. We have to do u values. So in our case, we'll have to change our x values to u's. So you do that by using our original equation that we did for u. So u of 3, basically. So u of 3 is equal to 2 g of 3 plus 1, and u of 0 is equal to 2 g of 0 plus 1. And we use the chart to figure out what that is. So g of 3 is negative 2, so I get negative 4 plus 1, which is negative 3, and g of 0 is 5, so I get 11. Now be very careful when you put these limits of integration in. You do have to put them in the same order. So 0 turns to 11 and 3 turns to negative 3. And now that you can put in your calculator. When you go to put things in your calculator, because I had a question asked before, when you do your integrals, do you have to put u's in your calculator? And the answer is no. Just put x's. Remember we talked about that? We call that a dummy variable. So as long as all the variables match up, you're perfectly fine. So you could put it in the calculator as cosine squared x dx, and that's perfectly fine. There is no rule saying that I have to have u's like in the calculator. So for instance, if you really wanted to, and you just like the letter p, these two integrals are exactly the same thing. This variable on the inside is what we call, again, a dummy variable, and this tells you what variable you're integrating. Once you get to higher calculus, you'll have multiple variables, not just one variable inside of there. So that will happen in higher level math, but for now we have just one variable, and we call that a dummy variable, so it doesn't matter. We can change them all out. So when you do it in your calculator, just do dx's. Any questions on anything I did? And again, I'm not expecting you to have gotten that necessarily by yourself. That's one of the more difficult questions. right there, Will? Okay. All right. So then moving on to 3, if nobody has any questions about what I did. All right. Number 3. Which the following is an antiderivative. Okay, so it definitely can't be A or B. Hopefully everybody realizes that. What happens when I take the derivative on A?
Yeah, chain rule.
I have a chain rule. When I take the antiderivative, or take the derivative, sorry, I'm assuming that's a typo they made. That should not have been x to the 5th minus 5, but it also may have supposed to have been. Remember, you don't mess with the inside. So regardless of what, if you forget the chain rule or not, that's not going to be correct. Why is it not going to be part B? Or answer B?
Quotient rule.
Quotient
Yeah, it's
rule.
quotient rule. It's definitely not going to end up being something simple like that. So it's C or D. In other words, they are testing um, the fundamental theorem part 2, where you take the derivative of an integral. So is it going to be C or is it going to be D at that point? That's the question you have to ask yourself. So we have to remember that when we do the derivative, you also have to do a chain rule on your bounds of integration. In other words, if I do C, I'll plug in x squared, but then I have to multiply by the derivative of x squared. So that will not get me the answer choice, or the answer that I'm looking for. So it has to be answer choice D. Does everybody understand what I mean when I say you have to do the chain rule on the limits of integration there? Does that make sense? If not, please ask.
Huh?
Hey, Dad. So again, to repeat, when you're doing your derivatives of your integrals, you will have a chain rule on the limits of integration. So for part C, I'll plug in my limit, so x squared, and then multiply by the derivative of x squared. Well, there is no 2x inside of the original function, so it can't be C. However, if I do that with part D, I plug in x, and then multiply by the derivative of x, which the derivative of x is just 1, so that's perfectly fine. Okay, moving on to number 4. Okay, hopefully after all of our conversations yesterday should not have been the end of the world. So first thing you want to do is do what? Any suggestions?
Take.
That'd be a great idea. Let's take the derivative because we need to find out what f prime is. It's not just straightforward. So please do not just look at the slope or something like that. That's terrible. When they give you a function like this, it's going to be more complicated than that. So what is f prime of x? Somebody besides Miguel, since Miguel figured out we're doing the integral.
F prime of what?
F prime of x.
I didn't know if that's what you said or not. I was confused.
Yeah. First thing we do is find the integral, and then we'll plug in the 3. Or the derivative, not the integral. We're doing the derivative of the integral.
Wait a minute. F prime of t just like the normal, not normal, but like the regular function of g of t?
No. It's the integral from 4 to x squared of g of t. How do we take the derivative of an integral?
FTC?
Well, yes, it is the FTC, but how do we do that?
By taking the derivative.
Thank you, Thomas. What does the FTC tell us that when we take the derivative of an integral, what happens?
Oh, it's the same thing as the function.
Okay, however, we have to be careful of one thing, just like I mentioned in the last problem, which is
The chain rule.
the chain rule. So it was 4x squared of g of
Why have we never used the chain rule on that before?
We have every single time
Yes,
we
we
did a
have.
problem. You guys, for
I
some
do not
reason, and I'm not like trying to, but for whatever reason, you all thought or think that this is the most difficult. Well, stop hitting your microphone.
Thought it was
And
muted.
we have dummy 1 and dummy 2 who find that funny. All right, so we've always used the chain rule. We've always talked about this. Remember, and we've done this I don't know how many times now the past couple days as well. D dx. The integral of lowercase g of t will be g of capital X squared minus g of capital 4. If you need to write it out this way, you can. You don't have to write it out this way. Well, the derivative of capital G, as we've talked about, is lowercase g, but then you had to multiply by the inside, so times 2x. Derivative of g of 4, that's a constant, goes to 0. So what did I do to get from here to here in a quick step, which you can take the shortcut, it's not a big deal. You don't have to show this out. This was asked yesterday. You don't need this line. This line is irrelevant if you don't need it. If you need it, write it. So the top line, if you notice what I did is I plugged in x squared to my g function and then multiplied by the derivative of it. I technically did the same thing for g of 4. So if I do g of 4, well, what's the derivative of 4?
0.
Times 0. So that goes by. So I've done that on both sides, except for the issue with the if it's a constant, when you multiply by its derivative, it's going to be 0. So it's the same way every single time. So we're looking for now f prime of 3. So I just plug 3 in. So g of 9 times 6. So all we need is the value at 9, which they didn't explicitly give us. We have to look at the graph for, which is a pain. Is it? Well, they made it not too bad for us. It's 4. So 4 times 6 is 24. You cannot forget that part of fundamental theorem and calculus as well, as I believe that part will also show its head on the exam. There's almost no way I would say they'd get away with doing an AP Calc exam without having both parts of fundamental theorem there. Okay, moving on to number 5. Well, sorry, is there any questions on anything I did before we move on? Okay, moving on to number 5. They told you what the U was. Okay, no big deal. The issue is, and I'll warn you, the problem that most people are going to forget to do, especially when they give you the U, is don't forget the DU. So you do have to make that substitution as well. So there's a couple things you have to do on this problem, so I'm sure I'll probably do it. You have to solve for x and make that substitution as well as your du substitution. I'm going to assume I need to do this one, yes?
Yes.
Okay, so u is 4x minus 3. It's the integral of what? X, 4x minus 3 to the 10th dx, right? So I got that right. Okay, so we're going to need a couple of things. So we have a one straight substitution. The problem is we still have this x over here, so we've done this multiple times in class. So I'm going to solve this for x. So x is equal to u plus 3 over 4. I also need a du function, which is 4 dx. And I'm going to solve for dx, so 1/4 du equals dx. So this is not something we haven't done in class. We've done this multiple times before with problems like this. We just are going to need all of those substitutions. So very easily, the u being 4x minus 3, I'll sub in to my parentheses, so I get u to the 10th. The x is the u plus 3 over 4, and dx is 1/4 du. So at that point, I just need to kind of simplify and move things around. I'm going to take the denominators of 4, multiply them, and move them out front. So I get the 1 over 16, integral of u plus 3, u to the 10th du. And then they distribute that, it looks like. Yeah, okay. So hopefully at that point it shouldn't be too hard to distribute the u to the 10th in. So 1/16 integral plus 3u to the 10th du. And even if you didn't distribute u, there's only one answer. That's 1/16. So makes sense, hopefully.
Yes.
Any questions before I move on? Okay, question 6. Really only option here for integration is substitution. We've talked about doing this before, so what is our u going to be on number 6?
6e to the x plus 3.
Yeah, pretty much. I mean, there's only so many options you could have picked. Obviously, it's not going to be the sine part because there's no cosine in there as a derivative. E to the x, if it's just e to the x, you're going to have some issues because you're going to still have a u out there. So e to the x. Sine, was it 6e to the x plus 3, I think?
Yeah.
Yeah. So our u will be, remember, usually it's your more complicated stuff that you can then take a derivative of and get something else in the problem. So it's a terrible u. So in our case, it will be r6e to the x plus 3. So then our du will be 6e to the x dx. And if you notice in the problem, we have an e to the x dx. I just need to move that 6 over. So 1/6 du is e to the x dx. And then sub in everything, and it shouldn't be too hard at that point, hopefully. So we get sine u, no, 6. And then the e to the x dx will turn into 1/6. I'm going to move that 1/6 out front. And we get a hopefully relatively easy function to integrate, which we have in this case. So what's the antiderivative of sine of u?
Cosine of u.
Careful.
Negative cosine.
Negative. And then don't forget your plus c. And then I'm sure they didn't leave it as a u most likely, so we'll have to take our u and replace it back in. Okay, and worst comes to worst, give you a little tip here. Just take the derivative of the stuff they gave you if you need to double check things. So when looking at these problems, the answer can't be D, as we just pointed out, because the antiderivative of sine ends up being a negative cosine. A would be a product rule, which definitely would not result in the derivative that we have there. So it's going to be B or C at that point. So there are ways on the multiple choice questions, which you unfortunately won't get this year, to help you, but those are always things to think about going forward, not just for the AP test, for things in general. All right. Number 7, I'm going to assume probably. Did anybody get number 7 correct?
I did.
For real?
Uh-huh.
How did you know what to do?
I did.
But I guessed.
Okay,
I
I
did
just,
too. I also guessed. Shocking, I know.
I didn't guess, but
I got number 7 correct too.
okay, who actually got it correct without guessing?
I didn't guess, no.
I did.
One person?
I think it was like a informed guess. Educated guess, that's what it's called.
Informed guess.
What is it? How did you educatedly guess this then?
No, I actually didn't. I just Yeah.
Yeah. So I would not have expected many of you to get this correct without guessing. And not necessarily guessing, but you could have also looked at the derivatives and looked at the answers and taken some derivatives. Is probably what I would have figured most of you would have done that did get it correct, because this is completing the square.
Oh, really?
Yes, we
Yeah,
talked
that's
about
not what
this.
I
We
did.
did quite a couple examples like this with your arc sines and arc tangents and stuff like that, where you have to complete the square in order to do it, and it's not an easy way of getting arctan stuff like that. So if you get something like this, my suggestion would have been to take the derivatives of some of them. Clearly, it's not an ln, because if it was an ln, you would have something on top that would be the derivative of the bottom, which does not happen here. So a is thrown out right out the gate. Um, it's also going to have to be negative because you have that negative in front of the x squared, so you're going to have to factor a negative out. So that's where you're going to get it's B or C at that point. So those things are what I would have suggested previously. Obviously, you may get an arctan, but it'll be free response now, so you will have to look for that. So anytime you get something that looks like this, so it's 1 over x, a polynomial of x squared, so quadratic, highly likely that it's going to be arctan for you guys in AB. There are other things it could be, but not in AB. So, do we remember how to complete the square?
No.
You do the
Can you like divide it by 2 and square it?
yeah.
Add it.
Yes, something along those lines, which becomes infinitely harder in this problem because it's not an equation where you guys are used to adding it to both sides. We talked about this and did a couple problems like this. You can't add it to both sides. So what the crap do I do? Well, remember we talked about this is where you have to add and subtract it is the method that I use for it. It's not the only way to do it, but that is how I do it. So we'll show the completing of the square of what negative x squared. So a couple of things we have to do here as we do this one. So if you have 1 over negative x squared plus 6x, was it plus 10, minus 10?
Minus 10.
Thank you. So a couple of things to do here. The first thing is to factor out a negative out of the bottom. You either put it out front or up top. So I always put it up top, so you get negative 1 over x squared minus 6x plus 10. So we're going to need to complete the square on the x squared minus 6x plus 10. So in order to do that, we do have to cut the 6 in half, square it, and we get plus 9. And then I subtract 9 at the end. So the plus 9 and minus 9 will cancel each other out. That's how I do it. No, it's not the only way to do it, but it's just how I do it. So this would become plus minus 3 squared plus 1. And then don't forget, I highly suggest doing your arctangent. You do a u sub, so you would do u is equal to x minus 3. In this case, it doesn't make any difference. So we go to integrate. I'm going to move you can move the negative out front at that point. X minus 3 squared plus 1. When you go to sub everything in, you get negative integral 1 over u squared plus 1 du. And we have to recognize this automatically as being arctan. So tangent of u, which is negative arctan of x minus 3. And then don't forget your plus c. So that is not the easiest thing to recognize. But again, as you're writing things down on a sheet to kind of study over things and look at things and have for your AP exam, because you can now, definitely might want to be putting on there 1 over a quadratic. In other words, a squared polynomial is likely to be arctan. And if it was a square root on the bottom like that, it's a likelihood of being an arc sine. Those are all things that we should be making notes to ourselves. Any questions on anything I did? Okay.
Excuse me.
Well, now that I've given you that hint, what do we think about number 8? For those of you that haven't done it yet.
Arc sine.
arcsine. So it's going to be pretty much the same concept. You're going to have to complete the square again, which completing the square is not always going to appear with arcsine and arctan. Sometimes you just need to rearrange and factor things. So the fact they threw 2 completing the squares in here is kind of a
What is
pain in the butt.
square do? I forgot.
What is what?
What does it give you when you complete the square?
A perfect square polynomial that you can factor.
Like that's the point of completing the square, like you being able to factor it.
Yeah, what you're doing is you're completing x minus 3 squared. That's why it's called completing the square, because you're completing something and making it into something that is a perfect square. You're just basically rearranging the problem to be something squared plus something else, in this case. So you would have done it in all kinds of different problems, like you did it in pre-calc to be able to get your ellipse and your hyperbolas and parabolas, all that kind of stuff, circles. So it's very nice and easy to deal with something that's individually squared, because we turned x squared minus 6x plus 9, we turned that all into x minus 3 squared. So it becomes much easier to deal with. Okay, so I'm going to leave number 8 for you to practice on your own. Obviously, they give the answer there, but try to practice that on your own for completing the square and see if you can get that one. Number 9's a pain. Obviously, it gives you the clue in the title, but how do we know what to do on this problem? So what's the key thing to recognize here on number 9? Sorry, not 8.
Long division.
But how do you recognize that? That's the thing. Is again, the whole point here
The
is you can
title.
make notes to yourself. That's why I'm saying besides the title, how do we know that this is a long division problem? So previously we knew it was a arcsine or arctan problem because it was a 1 over x squared, or 1 over the square root of something squared. How do I know this is a long division problem?
The bottom is less than top.
There you go. Anytime you have a problem that looks something like this, that's polynomial-esque, if the top degree is bigger than the bottom degree, that is going to be your hint that it is long division. It's a pain in the butt. It's not something that is super common or likely to appear, but it is something that's possible to appear. I don't think it'll appear, but you never know. So you'll make sure you want to practice your long division, which we've done before, with your polynomials. And if you have questions, send those to me individually. Because I want you guys to practice these topics on your own without me just doing them for you. If you need help, obviously ask me for help. It's not that I won't help you, but I want you to practice some of these, what we would call basic techniques that you've done before on your own. And then once you do that, the integral is actually super easy. It's not a very difficult integral. Okay. Number 10.
That one was easy.
Huh?
10 was easy.
Yeah, 10 looks pretty easy because it can't be some of these things that they're putting on here. So B is definitely wrong. Please don't ever do that. I don't think anybody in our classes have ever done that because I've never seen it. But please don't ever do B. We definitely know that C is wrong because they didn't do their dx substitution. So that's the easy distractor there is C. And with D, you can't pull an X out in front like that. I don't know where they got that. Oh, that's the DU. Yeah, don't ever do that, please. So A is the obvious choice. Remember, if it's easy to make into a polynomial, make it into a polynomial, and that's exactly what they did. They actually did the distribution out there. Okay, number 11. Shouldn't be too bad, hopefully, because they kind of gave you the choices. Again, never do A or B, ever, ever, ever. At that point, you just have to be able to do your U sub correctly, because if you look at C and D, they're both U's. So just make sure you do your DU correctly. Don't forget to do the DU. That's the part that a lot of people mess up on. So the answer choice being C there. Okay. Alright. Number 12. Number 12 is a little difficult. We've done a couple like it before, though. What the heck is C? What? What? Where? Oh, God. Okay, so I'm going to assume everybody knows the answer is not C or D by now.
Yeah.
Okay. So the question becomes, how do you get your bounds at that point? What is your U sub, et cetera, et cetera? So you're very limited on your options for U. So obviously I've told you it's never going to be X. So X is not the option. So the only other option really at that point is something like 1 over X. You could do like 1 over 2 plus ln X or whatever. But remember, I kind of gave you guys some hints to do this problem. Write everything out individually. So break it apart into smaller pieces instead of looking at it as one large picture. So remember, this is equal to, so 1 over X, ln X plus 2. I can write this out as 1 over X times 1 over ln X plus 2 times dx. So break it up into smaller pictures so you can see what those pieces are. Notice you cannot break up the ln X plus 2 or 2 plus ln X, doesn't matter how you write it. That is not, you can't break that up into multiple fractions. That is a denominator in of itself. So at this point you have a couple of options for your U. So if you just kind of work through them all, that's fine. It could be 1 over X. It could be 1 over ln X plus 2. It could be ln X plus 2. It could be just the denominator. Or it could be X. So a couple of those obviously are not going to make much sense. I've told you already that X is not going to happen. If it's 1 over ln X plus 2, then you get extra ln's and things. So it's not going to be that one. And it's not going to be 1 over X because I'll never get an ln that way. So it leaves you with the only viable option to start with being ln X plus 2. And that ends up being your derivative, or your U, because then your derivative is 1 over X dx. So your U goes there, and your du goes to both of those. So you, again, the easiest way on some of these problems like that is just to break it into specific, like multiple parts like that, and then say, okay, well, what are my options for U and du? What am I going to do there? How am I going to make it that? And just start kind of working through them. Like I said, it's never going to be X. It doesn't make any sense to be 1 over ln X plus 2, because then you're getting all kinds of like quotient rules and weird things like that possibly, and not going to happen. And 1 over X just doesn't work because you don't get the rest of the function to substitute out. So the most viable option to try is ln X plus 2, which does work because then I can substitute everything in. And then just don't forget, notice how on part B, they did not change the limits of integration, or answer choice B, not part B. So that throws that one out the water. That's why B is not correct. So A ends up having to be our correct answer where we plug those limits in. So even if you don't necessarily figure out what the limits are in this case, you could figure out the answer choice. However, again, remember, you're going to need to remember to change your limits of integration. Excuse me. Any questions on that one? All right. Because only about 5 people have looked at the FRQ, we won't start that today. We'll do that tomorrow. And don't forget, you need to also be working on your Cambridge stuff. So far it looks like only maybe one or two of you have started doing anything. Last I checked anyway. So do not forget you need to have that done. It's got work to be done with it, so it's not going to be I can do this in 30 minutes. Please don't try to wait till like tomorrow night to do it and things like that. Because I do expect to be able to get through probably all the free response tomorrow. It's only 3 questions. I think it's only 3 if I remember right. So I expect to get through all, if not almost all, of the free response tomorrow, and then we will start the Cambridge stuff on Thursday. So please do not forget to work on that stuff, guys. Anybody have any questions for me before we end class today a little early?
We have to actually submit anything for ACE Math.
At this point, I'm not making you. If I need to change up that tactic and make you submit it, then yes. But as of now, no, I just want you to do the problems and make sure you have them and have questions for me when we start going over them. If I feel people aren't actually doing them and aren't participating in class, then I will start making you upload your submissions as a due date, which is something that's very fastly approaching. Because I have very sinking suspicions that a lot of people are not doing work, which means I'll also be doing the same thing on the AP classroom. I don't want to do that. I preferred not to do that. I was trying to be very lenient and understanding, but people are making it very hard for me to do that. Okay. Any other questions?
I have a question, but it doesn't pertain to math, so I'll just wait until later.
Okay. Yes, Ashley.
I forgot my login for the Cambridge thing.
Like your password or your username or what?
Like both. Like I have no idea what I signed up with.
What? Like what? Bruh.
Maybe it's stored in your neck.
I can send you your login. I can reset your password if you don't remember your password. I will message you your login.
I think I screenshotted that really long number, but I didn't realize it. But I just thought I'd let you know.
You're fine. Here, I will message you your username right now in Discord, so it's there for you. But your password, if you need me to reset your password, if you can't figure that out, let me know. I can click the reset button, and I'm assuming it'll send an email to the email you registered with. Okay. Any other questions that anybody needs help with or anything? Okay, please make sure you're doing your work for tomorrow, especially those of you who have not done your work for today. Valeria, what is your question, sweetie?
Okay, so you know the math classes that we've taken like on Wake through Gulf Coast, like trig and pre-calc and stuff.
Uh-huh.
So how do I figure out if that transferred to my college?
You'd have to figure out if they accept the credit from a state college or not. Some do, some don't. It also depends on what credits are required for you. If pre-calc and trig aren't math credits for you, and like for a lot of people they won't be math credits, they're elective credits because they don't count as a college level math at actual college. So it just depends on what degree you're seeking and what they count for.
How do I figure that out?
Go look at your degree audit.
Fine.
Where are you going, Valeria?
State.
Where?
Florida State. Tallahassee.
FSU.
Yes.
What is your intended major?
Biological science.
Say that one more time. You're breaking up at the beginning, sweetie.
Biological science.
Still breaking up at the beginning.
Oh my gosh. Can you hear me?
Yes.
Biological science.
So you need so you need pre-calc, trig, and then calc 1. So
That's
your
it?
pre-calc and trig probably will transfer over. Your calc 1 will only transfer over if you get a passing grade on AP.
Okay, so as in like what happens if I already like what if I'm done? Like say I pass.
Okay, so when you pass, yes.
What do I do? Like do I have to take another math?
According to their academic map, no.
Oh my gosh, that would be so cool. I'd never have to do this ever again in my life.
Yeah, you will have to take a physics course though.
That's gonna be so bad.
Oh, it's only like someone tried to prepare you for that.
Okay, listen. Everything I've like learned, not even learned because I think I just blocked that entire semester out of my head.
Mm-hmm.
I forgot it. I already forgot it.
I know. But yeah, you have you only need calc 1, and then you're done with math. But you have a physics course.
Yes.
And that looks to be about it as far as that stuff goes. And it's a lot of obviously biology and chemistry.
I will be here every weekend for tutoring. Yay!
Okay.
Okay.
That's
all. Thank you very much.
I mean, if only you would have just stuck it out and passed A physics.
Is that true? Because like I just looked at it. I looked at the ACE stuff because I found the ACE stuff, and had I passed ACE physics, I would have gotten the credit for it.
That's what I just said.
That is so sad.
I know, right? It's only like someone was pushing you to succeed to help you in your future endeavors, but it just wasn't understood by the participant.
I feel like if
And
you would have explained the college part, I would have at least tried.
I did.
I don't remember that.
Where I told you that you'll get physics credit, and if you don't need physics for anything, then that's all your physics you'll have to take. Just like I told all the people in calculus that if you pass this test and you don't need anything above calculus, you'll never take math again. There's
Okay,
reasons
so like
I have standards.
Flagler, as soon as you pay like the entrance fee or whatever, they make you take a math like exam to figure out where you'd place in their like in math courses for like general eds or whatever.
And you got algebra 1?
And shut up. But that makes I don't want to take any more math.